So part of what you guys have to notice about this problem is I picked the slope of that very carefully, because where does it intersect that circle? And hopefully you can identify that quickly as the top half of the circle radius 5. Right? No? Yes? Maybe? That's what calculators are for, Jack? Alright. So we're going to 3, 4, 5. Right? So this is going to, so go up 3 over 4, that is going to be on that circle. Because then this radius would be 5. 3, 4, 5. Kick ass. Yes, sir?
Answer is 200 pi over 3.
I have no idea. Sorry. Okay, so real quick, I want to show you why shells. Does anybody see why shells would suck? How would you have to draw the shell if you wanted to do shells? I'm going around the x-axis. Standing up or laying down? Laying down. So do you notice something bad? Here's a rectangle, but what happens somewhere? So it goes between this and the line, but then what happens up here? It goes between this and the freaking circle. Shit, so there's a point where things change. Do you guys see what I'm saying? So I really don't want to mess with that if I don't have to, right? First I have to solve these for x, and then I have to set up 2 integrals. Do you see? So I can kind of semi-quickly tell shells is not the way I want to go. Alright, so let's stay away from shells. So instead, if I do discs, let's just focus on this here. So if I do discs, first off, this is going to be integral d what?
Dx.
Dx. I love it. So discs are nice that way. And again now, to get your inner radius, you start drawing where? Inner radius is going to be from what to what? What's my rotation axis? X-axis, so it's going to be from here to the first part I hit. So that's the inner radius. So what is that inner radius going to be?
So it's going to be 3/4.
Yeah, so that's the line. So that's 3/4 x. I'm going to stop there. I mean, there's nothing magic about that. The radii are going to involve the functions from the problem. You only have to worry about adjusting them if the axis isn't the y or the x-axis. They're going to add or subtract something from that function. And then the outer radius, what's that going to be?
Square root.
Yeah.
Minus x squared.
Kick ass. Cool. So then here, I'll put pi. What goes inside here?
25 minus.
Yeah, it's going to be pi r o squared. So remember, it's basically pi r squared. You've got these areas of disks. You're going to add up a bunch of them to get a whole volume. Because on the test, a few people forgot to square them. And this would be a really bad place to forget to square them. 25 minus x squared squared minus
9x squared.
3/4 x squared. I like it. So there's ro squared, r inner squared. And now you just got to, so now be pi integral. This is nice. Bam! 25 minus x squared. Please don't foil that. Don't square it twice. That sucks. The square died on the square root, and then this will be
9 squared.
cool.
From 0 to 4.
Good. I like it. So the limits from 0 to 4, that's what my x's are doing. And, one little tiny thing, simplify before you do, because what is negative x squared minus 9/16 x squared?
Negative 25x squared over 16.
Yeah, minus 25 over 16 x squared. And what do you get when you integrate that?
25x minus 25/16.
Yeah, 25x minus 25, it's going to be x cubed, so I'm going to do it over 3, but there's already a 16 down there, so now it's going to be 48. You guys see that? It'll be 25/16 times 1/3 x cubed. So now it's going to be 48 down there. And now this should be the easy step. I mean, one side is 0. That's awesome for polynomials. I just got to throw a 4 in there, and then I'm done. So I get 100 pi minus, who the hell knows, what is that, 400 over 48?
So it's
Is that right?
25.
Or 1600? 1600 over 48?
100 over 3.
100 over 3. I like it. So I got a whole 100 pi minus 1/3 100 pi is 2/3 100 pi. So it's 200 thirds pi. So we said, good. So either we both got it right or we're both very wrong. And one nice thing about it is it's positive, right? It's true volume. So I don't care if even my region is, wherever my region is, the process is set up to find the volume. So it should come up positive. Cool. All right, now try number 3. Can somebody tell me why it's very obvious what method you want to use? Yeah, since we're going around the y-axis, disks would require integral dy, which would mean my functions would have to be in terms of y. Can I do that?
Yeah.
Not easily. You actually could, but I really would rather not. So screw this method. Do you see how that's the part of the process? Well, this method will require dy. I don't want to do in terms of y, so I'll do the other method. Now you've totally focused on what that other method requires. Okay, go for it. Well, it's bounded by those two curves, so I don't have to tell you anything else. That first one was it had a whole other half of a circle there, so I was like, oh crap, first quadrant. But this one I don't have to tell you anything else than that. Cool. Hopefully I made a problem that works with that one. Let's see. Yeah. Your fort. Everybody brought their pillows and blankets. Yeah, too bad for you guys. Show some boring old stuff. All right, let me try to catch up to you guys a little bit. So, what'd you do first here? What's the first most important thing to figure out? Where they meet. So hopefully to the point where you realize you set them equal, so then you subtract part of it over to the other side. You get 2x squared minus 12x plus 10 is 0. Kill a 2. Right, that 0 eats that 2 up. And then that factors. Thank you, Ask Jeff, for getting one that works. That's awesome. So then 1 and 5. So now you know how to focus your sketch. And your sketch's scale can suck so bad, it doesn't matter. As long as you have them in order. Like don't put 9 here, then 8 there, for example. That's the only thing you have to be careful. So I know I'm going from 1 to 5. So at 1, it doesn't matter who I use because they both agree. So at 1, they're both going to be at 9. You see that? So let me put 9 there. Bam. Now what do you guys, anybody get further? At 5, where are they?
25.
Yeah, 50 minus 25 is 25. I like it. And you can double check to put a 5 in there, but you know that's where they meet. That's the first thing you did was figure out what they meant. So they're at 25. Look at that scale, it's awesome. So the next thing you realize is, I mean, this one is what kind of parabola?
One's downward, one's up.
One's down and one's up. I like it. And what I kind of do is I'll put a 3 in there, just something in the middle. Not to verify necessarily who's on top and bottom, because I know that's going to be the top is a downward parabola, but just to see where the hell he is to make my scale, my picture a little bit better. 30 minus 9 is 21. That's incredible. So at 3, it's there, so it's growing like that. And my other little dude, if I put a 3 in there, it's 9 plus 10 minus 6. Did I do that right? Where am I at? Yeah, put a 3 in there. 9 minus 6 is 3 plus 10 is 13. So he's going to be about right there. So he's going, wee-haw. It almost doesn't matter if your picture doesn't look like that. As long as this guy is on top, this guy's on the bottom. When you draw in your rectangle, it doesn't matter where they are. It just matters what the functions are. That's why your sketch doesn't have to be perfect. So I'm rotating around the y-axis. We decided we want to use shells. So it's going to be integral d what?
D1.
Yes.
dx. This would need the same, shells the opposite. Rotating around the y-axis, so it's got to be dx for shells. Let me stop there for a second. So then my rectangles are going to be standing up or laying down?
Stand up. Wait. Stand up.
Standing up, that's right. They got to be parallel to the axis I'm rotating around, so you're going to be standing up. Standing up, rotating around the y, laying down, rotating around the x. So I'm going to draw in a representative rectangle. So now the height just screams at me. The height is the difference in those functions. So what do I need? I need 2 pi, I need the height, I need the radius. So the height is the difference of those. What's the radius going to be?
X.
Good. So I find that on the x-axis. The radius is x. So it'll be 2 pi radius times height. And the height's going to be, oh, you gave yourself so much room here, Jeff. And the top one is which one?
10 minus x squared.
Yeah, 10x minus x squared. So it'll be 10x minus x squared minus x squared minus 2x plus 10. Shoot. Top minus bottom for the height.
Integration from 1 to 5.
I like it. And it's all about what x is doing, and x is going from 1 to 5. I like it. That's why that finding out where they meet is so freaking important, because it does inform your limits. If I was doing the y, if I was doing dy, my limits would be what?
From 1 or 9.
It looks like it'd be 9 to 25, but I would have to be a little more careful actually. But thankfully it's on the x-axis. Because I don't know if this really dips down. Maybe I have to find out where the vertex would be and all that kind of business. Thank God it's on the x-axis. It's easy. And now the rest of this should be the easy part, right? This is where you just distribute the negative, get your like terms together, distribute the x. It's a beautiful polynomial. That should be the easy part. I still get a few people that don't integrate. You feel like you did enough work. You get your like terms, you put the x, and then you start throwing 5 and 1 in there. But you can't do that until you've actually found the antiderivative, right? The big ass f. All right, so just a few people are doing that. I know it feels like I've done a lot of work already. Well, guess what? You got a little more to do before you start throwing stuff in.
This gives the same shells up.
Yeah, discs want the same. So whatever I'm rotating parallel to, discs wants d that. Shells opposite, which is one reason why together they can do just about anything. Whatever one can't handle, the other one can. Normal. Is that cool? I don't have to do that integration to them.
No.
Thank you so much. What about, that really should be the easy part, for that one especially. What about number 4? Let's look at this for a second. I'm rotating around something parallel to what?
X equals 0. Or X equals
So what would x equal negative 2 be parallel to?
y.
The y-axis. So if I use discs, I would want dy. And why does that sound like it might be nice? Because it's already in terms of y. So just gave away a big thing there. So try to set that up. You can work together if you want to. Or everybody's on Team Lone Wolf.
After the quiz. No such thing as quiz.
Okay. The boundaries have come down.
Yeah.
Every man for himself. The post-Quizopolis world.
Yes, no.
Ooh, that's kind of gross. All right, guys, some catch up to here. So again, you desperately need to get okay with this. I mean, that's easy to factor, right? So how do you factor that? So then y equals 0 and 2. So it's going to hit there and there. And again, I mean, I bet you anything it's going to be this, another little pregnant dude. But, pregnant dude.
It's not a baby.
So then 0, 1, 2. If I plug a 1 in, the same thing I did before, just to verify that it is over here. That would make sense with everything going on, that it would be over here. When I plug a 1 in, I get 6 minus 3. I get 3. So it is popping out over there. Cool. That's not even the vertex, but who gives a shit? I just needed to know which way it was opening. Right? Okay, I like it. I know that's not the vertex because it's not parabolic, so it should be symmetric around this vertex, and that's enough of that check. All that matters is I know it pops out over that way. Rotating around this, and we decided to use what method? Yeah, we're going to use discs, which requires integral dy. So what do I need to find? Here's my rotation axis, so I want to draw my radii always come off of that. So what's the first? So what's this?
Oh, that's
So it's
the
y-axis.
I want to make sure that you guys realize that is that wall there, right? So this is what I'm talking about, this region here. So what's the first wall I hit as I draw out? That one. So what's the inner radius?
1 or negative.
0 minus.
What am I rotating around?
0 minus -2.
X equals -2. So you want to make a big deal out of it. 0 minus -2, or just how far is this? 2. That's all. I mean, when you do big minus small, that's being careful because our brain is going around both sides of the axis and we're like, shit, what's going on? But the radii are just how far apart are these things. That's why subtraction comes in, because that's how it tells me distance. But I can just see that's 2 away. So the inner radius is constant along that whole interval. Is that cool? We've seen that kind of thing before. And what about the outer radius?
6y minus 3y squared plus.
Yeah, it'll be this curve minus 3y squared minus -2. So plus this extra 2. Plus the extra 2, right? So really, I mean, I used to try to teach this. If it's on the same side as your function, the axis is on the same side, it'll be minus. If it's on the opposite side of the y-axis, in this case, it'll be plus. That gets a little weird, but I don't know if you guys can see what I mean. That's why it's +2, because it's further away than it normally would be. And now the setup, you can see it would be kind of gross. What would the limits be?
0 to 2.
Good. It's dy, so 0 to 2. Put a pi out there. My outer radius
6y minus 3y squared plus 2.
squared, oh boy, minus the inner radius squared.
6y minus 1.
What always makes me cry a little bit was when people cancel those. Why can't you? Because that's inside here, right? You miss all the cross terms this would create. Makes the problem a lot easier. Takes less time to get the wrong answer if you do that. Right? But you're saving some time. But yeah, you'd have to, multiply that all the way out. Right? I mean, but that's relatively easy in the grand scheme of things. It just takes a little time. The most important thing, again, is can you set this up? That's the hardest part. That's the part that I'm going to grade the hardest on. And then integration, of course, integrate correctly, too. I will lose some points for that, too, if you don't. All right, so tomorrow I'll have the answer key for that practice test.
Huh?